Hello, today I'm going to talk about self-signaling. There's 3 steps in self-signaling. First step, reception. Second step, transduction. And the third step, response. Let's talk about the first step, reception. So GPCR is a receptor in the reception. So a ligand bonded with a GPCR, it changes the shape of a GPCR and go ahead activate the GPCR, and before that the G protein is bonded with a GDP. When a G protein bonded with GDP, G protein is in an inactivate state. But once the ligand bonded with the GPCR and it changes shape of GPCR, and it will go ahead bind with the inactivate G protein and causing the GDP to display the GDP. Now the G protein is activate, the subunit alpha subunit of the G protein will dissociate from the G protein next enzyme. So in this case, I put down adeninocyclase, which is an enzyme. So what it does after it got activate, it will go ahead convert take out 2 phosphorus group from the ATP and convert ATP into cyclic AMP. Cyclic AMP is a second messenger in the transduction steps. So if another enzyme, phosphodiesterase, can go ahead change the shape of the cyclic AMP and convert cyclic AMP back to AMP. After the G protein activate the enzyme, so now we also know that G protein can also hydrolyze GDP into GDP. So now the G protein is binding with the GDP, and now it is in inactivate state. Now the G protein will leave the enzyme and then return to its original place. Another receptor is the tyrosine kinase. So now we can see that in this picture we have 2 tyrosine kinase receptor. So a ligand bonded with each of them, and so now they got activated and they dimerize together, but it is not fully activated. So after they dimerize together, each of the tyrosine kinase region here will add on a phosphor group, a organic phosphor group from the ATP. So now total we need 6 ATP to break it down into like 6 phosphor group, and we got 6 ATP. So now we call this is fully activated state. So after the tyrosine kinase is fully activated, the protein will bind to each of the phosphor group, and so that's how the tyrosine kinase phosphorylate the protein, and then this activated protein can go ahead leading to a cellular response. Ion channel receptor is also another receptor. So now we can see this is a ion channel receptor. Once it bonded with a ligand, now is activate. So now the channel is open. Some specific ion can go through the channel and come inside. This is in the gate open state. So after that, if the ligand go away, then the channel will close, and therefore the ion cannot go through the channel. So now let's talk about the transduction phosphorylation cascade. What happened here is we have a receptor like the same we talked about before. When it bonded with a ligand, it got activated. and it will go ahead activate a second molecule. So what is this here? This relay molecule will activate the first protein kinase. So now the inactivated kinase is activate into a active kinase by taking out a phosphor group from the ATP. So the now it phosphorylate this kinase. That's why how it got activated. After a few steps, during a few steps, if an inactivate protein will got activate and then become a activate protein. So this whole step basically you just phosphorylate, add a phosphor group on the inactivate kinase and protein and become activate. Also a second messenger including calcium and IP3 and DAG. So for calcium, what it does is outside of the cell, the concentration of calcium is high, and also it is high in the smooth ER and also mitochondria. But inside the cytoplasm, the concentration of calcium is really low. So when a ligand bonded with the ion channel, the channel will be open, and then calcium can go through freely from a high concentration to a low concentration space. Also, in order to maintain a high concentration of calcium outside of the cell and also high in the smooth ER mitochondria, we have calcium pump, which against using energy against concentration gradient, and then pump the calcium from a lower concentration to a higher concentration. For IP3 and DAG, what it does is like I say, the GPCR got activated after it bond with a ligand. It go ahead activate G protein, and G protein activate a enzyme. We call this as phospholipase C. This enzyme will go ahead break down phospholipase into a DAG and IP3. IP3 is a second messenger. Once it bonded with a calcium channel, it will open the channel and allow the calcium from a high concentration to go into a lower concentration. And because calcium is also another second messenger, it can also help out to go ahead activate another protein and leading to a cellular response. So the last steps in cellular signaling is response. So there are a few response. So the first one here is we got the one in blue circle. All of them are the receptor, and then the yellow dots here are the ligand. So what is this? The first response here, we call it single response because the ligand bonded with the receptor, and you just go through one pathway and activate another enzyme, and at the end is only activate one protein. We call this one single response. In the second case, we have a ligand bonded with a receptor, and this receptor can activate another enzyme, but then this enzyme can activate another two enzyme or protein, so it's leading to like two different pathways. We call this is two response. One ligand activate two response. The third case here is we have two receptor and two ligand. So what it does when this two receptor is activated by bonding with the ligand. So the first one is to go ahead activate another enzyme and protein, but also the second one here, the receptor got activate and also activate another enzyme, but this enzyme can do has effect on the other enzyme or protein, because this one can activate this enzyme protein, or it also can inhibit the this protein or enzyme. So pretty much that's it. Thank you.